Hello everyone, I'm Ángel Varela from the University of Sevilla and I belong to IDEA Research Group. And this is the presentation of AMADEUS, our first approach to automate security testing. This is the outline of the presentation. First, we introduce the problem of tackling security testing in very high configurable systems, and we will see how this is a real challenge. Then, in the foundations, we will introduce some concepts necessary to understand our approach. After that, we will give an overview of AMADEUS, and we especially focus on the generation of feature models as the core of our approach. Finally, we will show a case study in which AMADEUS was applied to obtain certain feature models from vulnerabilities, and we will review some benefits and conclusions of our approach. Let's move to the work motivation. Nowadays, systems, software, even people of the organization are more and more exposed to multiple security threats. Then, the proper configuration of the system, even the software, have become a critical task to avoid security risks, to avoid security attacks. Indeed, OWASP point out that security misconfiguration is one of the most relevant security risks in web systems. That's it. A bad configuration of a web system can suppose a vulnerability of the organization. In the figure, at the bottom, we can see a summary of the vulnerabilities related to the new products and vendors in the last year, included in the National Vulnerability Database of the NIST. We can see how the number of vulnerabilities is very high, and this great variability is due to the number of new targets of systems such as databases, web systems, devices, network, etc. included in the vulnerability database. We need to manage this variability presented in the vulnerability information to test our system and the security of our system. Now we introduce some concepts necessary to understand our approach. To understand the security testing behind our approach, first, we need to introduce the ethical hacking process. The ethical hacking process is divided into 6 phases at least. The first, we define or identify the targets, for instance, a MySQL database service, a specific operating system, or any web server version, etc. Then, we need to scan the targets to look for some vulnerabilities. The vulnerability scanning can be done manually or automatically using any tool. For instance, we can search vulnerabilities for Apache HTTP web server on the National Vulnerability Databases. As we can see in the picture, there are almost 2,000 vulnerabilities for this system. These vulnerabilities are described using a format, a CVE format. This CVE format defined by Mitre, and we can go in depth the vulnerability and we can see the description, the impact, and even we can see the known affected software configurations that describe if the vulnerability affects an application, the vendor affected by, and the specific product, even the version, the date version affected by the vulnerability, and so on. These two formats, CVE and CPE, are the most relevant format used to represent the vulnerabilities. Then, based on this information, we have to orchestrate a test to exploit the vulnerability. And the last phase of the process is the reporting of the information collected in test. Our approach intends to help in the task of the identification and the vulnerability scanning to support the security testing. Let's go to introduce AMADEUS. This is the process that AMADEUS follows. AMADEUS can start in 2 modes, custom and automatic. In the custom mode, AMADEUS allows users to provide a list of terms and keywords for a set of target systems. In the automatic mode, AMADEUS invokes an analysis tool with a set of target systems. The information retrieved from these tools is tackled by AMADEUS as a list of terms and keywords, as we can see in the table at the bottom. The terms found in the reports obtained from the from the tools or provided by the user are essential in the search of related vulnerabilities. AMADEUS was integrated with a web scraper used to extract the vulnerabilities from the tags provided by the user or the tool. AMADEUS enabled us to extract the vulnerabilities in the CVE format from the National Vulnerability Database of the NIST. For instance, we can see two examples of CVE extracted from the database. By using the same scraper, we extract specific information about the known software configuration affected by these CVEs. In our case, we extract the CVEs that each vulnerability provide. And based on this information, AMADEUS builds some valid feature models. In our case, we construct a feature model for each CVE that gather all the information related to all the known software configuration affected by this vulnerability. This set of feature models compose a catalog of feature models that can be used in a huge variety of scenarios. Scenarios in which we can, for instance, generate attack vectors, or we can provide a configuration and we can check it, or we can also prioritize some attack vectors against others in function of certain criteria. We will go in details of the generation feature models from the configuration extracted for each CVE vulnerability. Following the same example shown in the previous slide, we will simplify the generation feature model following the same example. This is a synthetic example that represents a vulnerability composed of two lists of known affected configurations. The example represents a vulnerability composed of two lists of configuration 1 and configuration 2. Each one is a list of CPEs. In this case, the first configuration is composed of 3 CPEs, and the second is composed of 2 CPEs and 1 running configuration. The running configuration represents the environment in which the affected configurations can produce the vulnerabilities. For instance, here we can see that there is no specific environment in which these three CPEs can produce, but this one, the second configuration has one specific running environment in which these two configurations can be produced. The idea of the generation of feature model is divided in two parts. The first part in which we create the sub-feature models for each vendor. In this case, we can see the all-learning vendor that has one product, SciVet, and this SciVet has 3 different versions, and one of the version specifically in one language, French language, and the other 2 are in any language. And similarly, we build the three submodels. And the second part is focused in the restriction of this model based on the characteristic of each configuration. In the second part, we integrate and restrict those sub-feature models into a single one by joining the sub-feature models under the feature model related to the CVE identification. That's it. We introduce a superfluous feature that represent the name of the CVE, and to conclude the construction, we analyze the attributes of the configurations and we include some restrictions on the model. For instance, the French language is only permitted for the CPE1, or the CPE4 and 5 are only permitted under the running configuration of CPE6. These restrictions are included by using cost constraints. requires or more complex construct constraint in the model. Now we will show the result of the extraction of feature models in a specific scenario. The scenario represents a synthetic workstation in a corporate network, which includes some services and applications, for instance Firefox, Apache HTTP server, or a VPN client to connect to the workstation, and so on. We have developed a tool that enables us to infer the models from the most critical vulnerability of the service that in the case study. The feature models are retrieved in FAMA format, and one of the part of the experiment was to demonstrate that we were able to generate feature models in an acceptable time in the general case, and in the second part of the experiment is to demonstrate the current of the models and the usability of the applying some reasoning questions about the attack vectors and checking configurations. And to conclude the presentation with some remarks, this is the first steps to automate security testing. AMADEUS didn't cover the full ethical hacking process, but the next steps require to enable the integration AMADEUS with other security tools, even with other software product line tool in the field. The feature model generated enable to know about the vulnerability domain space of the system and software that we have in our inventory, and they can be applied in many security fields, even in other fields. To help the community in the use of our approach, we provide AMADEUS tool to the community in a GitHub repository. Even the models produced in the case study are given in the repository. Anybody can test, even can integrate the tools in other tools and discover how to generate thousands of feature models in seconds. This is all. We encourage you to read our paper for more information about the generation of feature models, and don't hesitate to ask any question by email or Twitter. Thank you very much.